You are watching the Target 8.1 retest video. In this video, we're going to learn how to graph absolute value equations and inequalities. And we're going to write some equations and inequalities too. So go ahead and grab your white packet. We'll probably do a few problems from that packet, and you should be able to finish the rest before you're allowed to retest. Here we go. The first problem we're going to do is number 1, which is an absolute value equation. So a little background with absolute value. Absolute value of any number is just the distance from 0. So the absolute value of -3 is 3. The absolute value of 3 is also 3. They're both 3 away from 0. So for that reason, what you're going to see is, since we have a linear equation on the inside, a line going up and to the right, a line going up and to the left, never getting to the negative side of the starting point. So you're going to see a lot of things look real similar to vertex form of quadratic, which looks like this, where h and k were the starting points and a varied the slope. So for absolute value, it looks like this. Again, h and k are the starting points, or your vertex, and a helps define your slope. So if we look at this one, remember it's the opposite of the one inside. So our vertex is -3 and -2. That is right here. And our slope, our a value, is 2, which is up 2 and over 1. So here is one side of our absolute value graph. And since we are dealing with an absolute value, it's also up and to the left by the same slope. So our graph ends up looking like this. Don't forget to label your vertex, and then domain and range. So domain, since there are no restrictions with the numbers you can plug in, it's going to be all real numbers. Whereas your range, if we follow the y-axis up and down, you see that it stops at -2 and everything is above. So y is larger than or equal to -2. Continuing on with number 3, I'll write the base form here again. Okay, and a lot of times some of these numbers don't look like they exist. So when h and k is missing, you know that they are 0. If you don't see an a value there, it's automatically 1. Reason being is that it's a times the absolute value. So in order to get that absolute value to stay the same, you multiply by 1. Whereas the other ones are added, subtracted, so they would be 0. So in this case, then you see a couple things that are different. A, it's an inequality, but B, there's no number inside here. So if you really wanted to rewrite that, there's a 1 in front, 0 inside for those things that are missing. So that gives us a vertex of 0 and -6. And our slope is 1, which is up 1, right 1, up 1, right 1. And also up 1, left 1, up 1, left 1. So here are a few points that we would draw here. And before I draw the line in, we have to know whether the inequality includes the boundary line or doesn't include the boundary line. In this case, since it's just less than, it's going to be dashed. Because it doesn't include, it's not equal to. Greater than would also be dashed. Whereas less than or equal to and greater than or equal to are solid, because they include the boundary line. A little off, sorry. All right, so now we have less than, and the way I want to teach this is it says y is less than, which means the number that you plug in, for example 0, you get -6. All the y's that we want are going to be less than that 0, -6 point. Less than in the y direction is all below, and it works that way for every point. So if we plugged in -3, for example, we'd get -3 back, and it would be y is less than -3. Well, that's all the numbers that are below -3 in the y direction, which is below. So when it says y is less than, we're looking at each and every point, and the ones we're interested in are the ones that are below. Okay, this changes our domain and range a little bit, whereas domain there still are no restrictions, so x is all real numbers. But range, notice that it goes forever in the negative direction. It also goes forever in the positive direction. Way out here, it's still shaded. Way out here, it's still shaded and it goes up forever. So that's why the range is all real numbers too. It won't always be that way, as we see in the next problem we're doing. So a quick graph of this problem. The vertex is -2, -6. Our slope is 5/1. Keep in mind that if this was negative, we'd be going down, we'd be opening down. This is up and to the right, also up and to the left. So let's start at -2, -6. Up 5 spots, both directions. Up another 5 spots, both directions. Last one is just off the graph. This one is also dashed because it's just greater than. And this is a y is greater than also. So that means for all these points, the y values that we're interested in are greater than. That takes us to the inside of this graph, shaded on the inside. So for our domain and range, domain still no restrictions on x. But our range now, notice the shading goes up forever, but it does stop at the vertex. So y has to be greater than the -6 value. That's down here. Now, that -6 value is not equal to it because it's a dashed line. If it was a solid line, it would be equal to -6, greater than or equal to. But this is a dashed line, so it's just greater than -6. All right, so that's enough on graphing. Hopefully you can rewind it and watch it again if you are struggling with it, or go and see your teacher before or after school. Let's move on to 12 and 15, and these, they want us to write the equation or inequality for these, and then state the domain and range. So the domain and range we should be able to do pretty easy here now. Domain, no restrictions, so all real numbers. Range though, it goes down forever, but it doesn't go up forever. It only goes up to 2. Everything's below it, so y is less than or equal to 2. Notice this one has an equal to because it's a solid line. This one is not dashed or solid. It's not shaded at all. This one is just an equation. Domain, still no restrictions. But the range, let's see, it goes down forever, and it's smaller than 5 the whole time. All right, now as far as writing the equations go, we want to fill in the a. We also want to fill in the h and the k. So we'll do number 15 first. It looks like it goes down 1 and right 1, so that means our slope has to be -1. And then our starting point here is -2 and +5. So keep in mind that h is opposite, x minus -2, so it's x plus 2, and then k is the same, +5. So there's the equation. Now this one is an inequality. Now keep in mind it's solid, so it's going to be less than or equal to or greater than or equal to, and all of these are shaded below. So this one must be a less than or equal to. The slope is down 1 and right 1 for the whole time, so that means the slope is -1, and our starting point is -2, +2. So when we write those in, we get -1 on the outside, absolute value of x plus 2, and then +2 on the outside also. So opposite of the x value, same as the y value. All right, that should get you going on the writing equations and inequalities piece. Feel free to re-watch that, or go see your teacher before and after school.